Hello, I welcome you to this 15th lecture session on Database Management Systems course. Here in this session, we learn about the transaction and the transaction model, transaction processing, significance of the transaction model, various states of a transaction and properties of a transaction. Multi-user database systems. Multi-user systems or multi-user access to the database simultaneously to provide multi-processing, and the advantage of this is increased throughput. That is, if multiple users are accessing or multiple applications or transactions are accessing the database at the same time simultaneously, it is definitely going to increase the throughput. At the same time, it is also going to create some problems with respect to consistency of the database, and concurrency there occurs, concurrency in data access. Transaction is a collection of operations that perform a single logical operation or function in a database application. That is, every transaction is there to provide a logical functionality which is part of the database application. Each transaction is a unit of atomicity. If we look at the storage types, we have volatile storage, main memory, cache memory, so on and so forth, and then we have non-volatile storage. That is, whatever data we store in non-volatile, it is going to be persistent or permanent. For example, disk storage and then tapes. If you look at the storage hierarchy, database system resides on non-volatile storage because the basic requirement of the data of a database system is that need to be persistent. It need to be stored permanently in the database. Database is partitioned into blocks of fixed length storage, which are units of storage allocation and transfer. That means, if you look at the database, every relation of a relational database will be getting into a file. We call it as a file, data file, and the file consists of a number of data blocks, wherein these data blocks contain the records, individual records. Transactions input and output data from disk to main memory and main memory to the disk. The data transfer is done in terms of blocks. That is, so if the data is stored on the hard disk, then when it is required to process that or manipulate the data, it need to be brought onto the RAM. Then only an application program can access the data and then manipulate that, and then once manipulation is done, that can be written back onto the hard disk. This is how, that is, the transfer of data between a hard disk and the RAM is in terms of blocks. The data block is the unit of transfer of data between a RAM and the hard disk. A buffer block is same as disk block, but it is in main memory, but the size is going to be same. The block available on disk is called as a disk block, and the block available on the RAM is called as a buffer block, but invariably the size of this buffer block and disk block is going to be same. The block movement between disk and main memory is initiated by the following operations, and there is a operation input X. The physical meaning that it means that the physical block with data item X is brought from disk onto the main memory. Output X, the buffer block containing the data item X is sent to the disk to replace the appropriate physical disk block. These are the basic operations that are used. It is like this. This is the hard disk and this is the buffer space, main memory, and input A, meaning that the block on the hard disk which contains the data item A is brought onto the buffer space. Then output B, once the manipulation is done, the data item, that is a block, a buffer block which contains the data item B is written back onto the disk. These are the basic operations performed. Transactions interact with database by transferring data from program variable to the database and database to the program variable. Suppose, let us assume that there is a program which has some instructions or code and which is supposed to manipulate the data contained in the database, and suppose the application program is supposed to manipulate, process the data item A which is available on the disk block and which is part of a record on the disk block. Then when it is time to process it or manipulate that, the application program need to bring that data block from the disk onto the main memory, and from this main memory, that is buffer, it has to read the data item into a program variable which is very much local to the program. Then the program can manipulate or process the data, and then it will be again returned back to the buffer. From there, the actual disk block will be replaced with the modified buffer block. This is how it works. This transfer of data is achieved through the following two operations. The first operation is read X, capital X, and then Xi, meaning that read the data item X into program local variable Xi, and write X Xi, that is write the local program variable to the data variable X, and read X where Xi is the local variable and capital X is the data item, database data item, and represents the operation. This is same as this operation, that is assigning the data item value which is part of the database, that is capital X, to the local program variable Xi. If the block with the data item X is not in the main memory, and it will in turn issue the command input X, because the program can access the data only when it is available on the buffer. So that's why if the required block is not available on the buffer, that means on the main memory, then it will in turn issue a command input X, that is a data block which contains the data item X will be brought onto the RAM. Assigning the local variable Xi, the value of X from the buffer block will take place afterwards, and then write X Xi, it performs this operation, that is assigns the value of the local variable Xi to the data item X which is part of the database. If block with X is not there, it will issue input X and assign Xi to the X in the buffer block. And reading is must, but transaction need not write every time. The modified blocks can be written back onto the disk during page replacement in main memory. That means whenever it is time to process the data, and it need to write the data block which contains the data item from the hard disk to the memory, and from there to the local program variable. But writing back onto the disk need not take place immediately once the processing is done, and it can be done at the time of page replacement for the main memory. Steps followed by transactions while accessing data for processing. It will first use this operation read capital X Xi, and if the data item X is not available on the buffer, it will in turn uses this operation, and once it is available in the RAM, then the data item capital X will be assigned to the local variable Xi, and the operations will be performed, or the processing will be done onto the data which is locally available in the variable Xi. Once it is done, it will use the operation write capital X Xi, and if it is it in turn uses the output X operation where the value of Xi will be assigned to the data item capital X. If the system crashed before the new value is written to the disk, then the new value is lost forever and never be returned to the disk. That is one big problem with these operations. A transaction is an atomic unit of work that is either completed in its entirety or not done at all. That is a very, very important property of the transaction. That means we group a sequence of instructions which try to read or operate on the data or write the data back to the database, and call this collection of instructions as a transaction. The major property of this transaction is either all the instructions or operations of a transaction are successful, or it is not done at all. It is not the case that only 3 of these are successful and remaining are not done. That is not the case with a transaction. It is an atomic unit of work that is either completed in its entirety or not done at all. So whenever a partly completed transaction is under execution, and when there is a system crash occurs, then we need to take care that to take the database to the previous consistent state, we need to remove the effects done by that half done or unsuccessful transaction. That is very, very important. For recovery purposes, the system needs to keep track of when the transaction starts, terminates and commits or aborts, and what are the data items that have been modified by the transaction. And when we have this kind of information available somewhere, whenever there is a problem or system crash occurs, we can always revert back to the previous consistent date of the state of the database by using this information which is stored in the log records. For the better understanding of the concept of transaction, let us have a look at this example. We have railway reservation system which is there to provide functionality, various kinds of functionalities to the end user. The first functionality could be find list of trains between two stations, and here data manipulation is not required, only data access from the database is required. Let us assume that this is the hard disk which contains the database. And second logical operation or functionality could be find number of beds available for a given train. It also involves only the read operation. That is, let us assume that there is a data item available and which actually stores the information regarding how many berths are available for a given train. And when you find number of berths available for a given train, then this application functionality, that is the piece of code, will be accessing or reading the block which contains this information, that is availability of berths, into the program, and it will process that, or it will, in this case there is no manipulation, that is there is no modifications are done to the data item, rather it is just read operation. So there is no problem. As far as the application program is concerned, if it is just reading the data item and not trying to modify that, then it will not create any problem. It will not create any problem with respect to consistency of the database. Now let us have a look at another important functionality of the railway reservation system. Reserve required berths for a given train, and this requires, first we need to collect the required seats from the user. Let us assume that the local program variable R is going to collect that information, then get the available seats into the local program variable A from the database, and if A, that is available seats, is greater than or equal to R, then I can provide reservation, or then he can do reservation, and A is equals to, then what I need to do, A is equals to the available seats minus the seats that are being reserved. That means I am trying to modify the data item A, which represents the available seats or berths for the given train, and once the this operation modification is done, then collect the money or payment from the user, then issue the ticket, and that ends this functionality. And otherwise, that means if the available seats are not equal to or not greater than R, it means that the required number of berths or seats are not available for a given train, then display a message that required seats are not available and end the process. And this functionality is there, and let us assume that there is no concept of transactions, or transaction model is not adopted for this database, and user 1 and user 2 are wanting some berths to be reserved for a given train, and let us assume that that data is available on the hard disk in the database, and the data item that captures or stores that information is available. First user starts this functionality, and in a multi-user environment, multiple users can start the same functionality or invoke the same functionality of a given application at same time. Okay, and user 1 starts the functionality of reserving the tickets, and he doesn't know that other fellow is also wanting to reserve some tickets, and he requires 15 tickets for a given train, and immediately this functionality or this piece of code is executed for the user 1. The required number of seats that is given by the end user will be taken into local variable R, and get the available, the function will get, that is this piece of code will retrieve the available seats for the given train and then store it in local variable A, and it is going to be 20. The required seats are 15, and if A is equals to greater than or equal to R, in this case it is certainly yes. So A is equals to A minus R. That means this particular instruction of this piece of code is trying to modify the data item A, which is a local data item and which represents the data item available on the hard disk or on the in the database. So A is equals to A minus R, then automatically it issues a write operation, and then this is now this is now 20 minus 15, which is equal to 5, and then he tries to collect the payment. Let us assume that after performing this operation, that is A is equals to A minus R, there is a crash, system crashes, and he could not collect the payment and he could not issue the ticket. That's why the reservation process for this user 1 is not successful. But this is an unsuccessful operation, but still this unsuccessful operation has modified the data item available from 20 to 5, and this is not taken care. Now let us assume that user 2 is also invoking this functionality to reserve some berths, and then he wants 10 tickets to be reserved, and again independent of the user the same functionality will be invoked. Now this value is only 5, and again he will invoke the same functionality. First instruction will ask for the required seats, and it will store that information in local variable R. It is this time it is only 5, it is going to be 10. The required seats by user 2 are 10. Then it will get the available seats from the database and store it in A. Now it is going to be 5, and when you execute this, that is if A is greater than or equal to R, then there is a problem. It says that the required seats are 10, the available seats are 5. Hence it will go to this, and then it will display a error message to the end user saying that the required number of berths are not available for the given train. And this actually, in fact, the 20 seats are available. When the first user tried to reserve his seats, and up to certain extent the code was executed, and when it was collecting payment and then before issuing the tickets, the system crashed. So hence the actual number of berths available, that is the 15 berths requested by user 1, are actually not issued or given to the user 1, and unfortunately the half done function, that is code execution, that has modified the data item available from 20 to 5, and because of this problem the second user, when he is requesting for 10 seats, he could not get the required berths, though they are actually in fact available for the given train. So this is the problem. To resolve this, that is, this problem has occurred because there is no concept of transactions. And now let us assume that this particular piece of code, which actually contains 1, 2, 3, 4 some number of instructions, is grouped together, and then this is called as a transaction. This is considered as a transaction. What is the basic functionality or property of a transaction? Either it will be done in its entirety or not done at all. That means when the first user invokes this will be done, and this is also okay, and then he modifies 20 minus 15 is equals to 15, 5, and that means it is temporarily modifying the database to 5, and after this there is a system crash. According to this atomic property of a transaction, the whatever changes that have been done by the half done transaction should be removed or nullified according to this. And when the transaction has been started, let us assume that the transaction is T101, and when the second user starts, it could be T105 or something like that. For every transaction I am going to store the information like what is the transaction 101 and it has started, and then what is the data item that has been modified by the transaction. The available seats is the data item, old value is equals to 20 and the modified value is 5, and after doing this there is the system crash. Because I want to nullify or remove the effects done by this half done transaction, I will be consulting the logbook. Once I consult this logbook, I will know what is the old value of the data item that is quite recently modified by this failed transaction, and I can also see what is the modified value. Then I go to that data value and then remove the effect done by this incomplete transaction, and I will revert it back to the original value, that is 20. That means the failed transaction has been rolled back. This I call it as, that is, removing the effects done by half done transaction onto the database is called as rolling back. Once I roll back, I will go back to the previous consistent state, and then onwards Now I can start, the user too can start his functionality, or he can invoke the railway reservation, that is he can make a request for reserving berths, and then automatically, since the available seats are 20 and he requires only 10 seats, and this can be honored. And this has been possible because I have introduced the notion or concept called as transactions. Because of that only it is possible. Hence, a transaction is an atomic unit of work that is either completed in its entirety or not done at all. That is the basic philosophy of a transaction model. For recovery purposes, the system needs to keep track of when the transaction starts, when it terminates, and when it commits, and then what are the data items that have been modified by this transaction. When there is a problem, I can always consult this information or data log and then revert back the effects, remove the effects done by this half done transaction. If you look at the transaction model, a transaction is a program unit that accesses and updates several data items. It performs the basic operations like read or write on the data items. And this is when the transaction is started and when it is under execution. Before the transaction is started, the database will be in some consistent state, and once the transaction is successfully executed, that will take the database to the next consistent state. This is consistent state C1 and this is consistent state C2, but at the time both of them are consistent, but during the time of executing the transaction, the database may be in some inconsistent state, and whenever there is a problem or system crash, when a transaction is under execution, that may leave the database in some inconsistent state. Hence, as a result of failure, state of the system will not reflect the state of the real world that the database is supposed to capture, and this kind of state of the database is known as inconsistent state. And it is important to define transactions such that they preserve the property of consistency for the database. That is very, very important. Now, what are the basic properties of a transaction? Transaction should possess the following properties, which are shortly called as ACID properties. A stands for atomicity, C stands for consistency preservation, I stands for isolation, D stands for durability. Atomicity means a transaction is an atomic unit of processing. It is either performed in its entirety or not done at all. That we have seen in the previous discussion. And consistency preservation property says that the successful execution of a transaction should take the database from one consistent state to the next consistent state. And isolation, a transaction should be executed as if it is not interfered by any other transaction. That means a multiple transactions that belong to different users, the end user should not have any idea about the other user executing his transaction. That means one transaction should be isolated from another transaction and at the time of execution, and these different transactions can access the data as if the transaction will think that as if the data is completely available for its operations or for its execution only. That could be the kind of impression that can be provided, and this is called as isolation. A transaction should be executed as if it is not interfered by any other transaction. Coming to the durability, the changes applied to the data by a transaction must be permanent and persistent. Now let us have a look at the states of a transaction, like how a process in operating systems can have states. Similarly, transactions can also have states. The first one is active state, partially committed state, failed state, committed state, and then terminated state. Active state, it is the initial state when a transaction starts. When a transaction starts, it will be in the active state, and that is going to be the initial state for a transaction. And once it starts execution, when it is in active state, it keeps on performing various operations like accessing data, modifying it, writing it back to the disk, so on and so forth. And once, suppose, let us assume that these are the instructions, that is, it has 5 or 4 operations. 5 operations are there for a transaction, and once it is started, it will be in initial state or the active state, and it can perform these operations. And once it has executed the last operation or instruction, then it will go to partially committed state. This state is reached when the last statement is executed and the outcome is not yet written to the database. That means all the instructions are successfully completed, but the final outcome of executing this transaction is not permanently written to the database. That is the case, and when it happens, that state will be in, the transaction will be in partially committed state. Then failed state, that is whenever, that is at the time of execution, whenever a failure is discovered, that is whenever some abnormality in execution is discovered, the transaction execution cannot continue and a transaction is aborted and it reaches the failed state. And committed state, and once a transaction reaches partially committed state, when it will reach partially committed state, when all the instructions of a transaction have been executed, then it will reach partially committed state. After reaching partially committed state, and that means when it is in partially, when it has reached partially committed state, it has not yet tried to write the changes permanently to the database, and after reaching partially committed state, it can now try to modify the disk for the sake of permanency. That is, it can try to modify the database permanently. That is known as, after it is done perfectly, that is the modifications are affected onto the database, then it will reach committed state. And once it has completed, that means when it reaches committed state, it will go to terminated state, or once it has failed, then also it will go to terminated state. This terminated state is reached after failure or success of the transaction. Let us try to understand these concepts using this diagram. When a transaction begins, it will be in active state. When it is in active state, it can repeatedly perform any number of operations like read or modify or write, something like this. Modify and then write, that is read, update and then write, all these operations. When the last instruction of the transaction has been completed, that is end of the transaction, it will go to partially committed state. That means even after reaching this, it has not tried to write the changes to the database. And suppose, let us assume that after, suppose it has 5 instructions, after executing 2 instructions there is a problem, then it will be it is aborted, it is known to be aborted, and when it is aborted, all the effects that is done by this half done transaction will be removed, and this is called as rolled back, and then the transaction will go to failed state. Otherwise, if all the instructions are successfully completed, then it will go to partial committed state, and here it will try to write the changes permanently to the database, and at the time of writing this changes to the database, there can be a problem. Then also it is there is a problem, there is an abnormality, and then it aborts. That means it is going to fail, and when abortion occurs, all the changes that have been, that is all the computations or modifications done by this transaction are removed, that is nullified, and it will go to failed transaction. Once it reaches the failed transaction, failed state, it will go to terminated state, and even once everything is perfectly written to the database, it will go to committed state, and from here it goes to terminated state. That means if it is reaching terminated state from this path, it is a failed termination, and if it is reaching termination from this path, it is a successful termination. This is how a transaction works. This is the life cycle of a transaction. Those transactions which are not completely successful are called as failed transactions. In order to ensure atomicity property, failed transactions should have no effect on the database. Hence, the state of the database must be restored to the state it was in just before the transaction started its execution. That is, before the transaction starts, the database will be in some consistent state, and once the transaction begins and during its execution, it may not be in some consistent state, and once it is successfully done, it will go to next consistent state, that is C2, and C1 and C2 are called as consistent states because the database will reflect the real world situation. Hence, it is a consistent state, but during the execution of this transaction it may be in inconsistent state, and if there is a problem, if the system crash occurs, only few instructions are successfully completed and the remaining instructions are not completed, hence that may leave the database in some inconsistent, meaning that where it will not reflect the real world situation. Hence once there is a problem, once abortion occurs, once it fails, the effects done by this half done transaction must be removed. When you remove the modifications done by failed transaction, automatically it means that you are taking the database to the forcibly you are taking the database to the previous consistent state, and from there onwards again you will have to restart the transaction. And once it is successfully done, all the changes have been permanently written to the database, then it will take the database to the next consistent state. And the process of removing the effects done to the database by a half done transaction is called as rollback activity. When the transaction rolls back, the modifications done to the database by the half complete transaction are removed so that the state reflects the state before the start of execution of the transaction. A transaction which is completely successful is called as the committed transaction. A committed transaction brings the database to new consistent state. The effects of committed transaction cannot be rolled back. That is, once a transaction reaches the committed state, then it cannot be rolled back. Once a transaction is aborted, it must be terminated and a new transaction for the same functionality or piece of code must be started. A transaction reaches committed state if it has partially committed and it is guaranteed that it will never be aborted, then only it can reach the committed state. In this lecture session, we discussed what is a transaction and basic database operations performed by a transaction. What are the desirable properties of a transaction, that is ACID properties, and what are the various states of a transaction, and when each of the state is reached, and transaction execution and the database consistency. And when a transaction is under execution, that may leave the database in some inconsistent state. That is why when a failure occurs, we need to take the database back to the previous consistent state, and from there again we need to restart the transaction. This is the transaction model, and when multiple transactions are being executed simultaneously or concurrently, that will definitely increase the throughput at the same time, and it may leave the database, that is, it may create lot of problems in terms of consistency. That is why in the next class we will discuss about how to control the concurrency with respect to the execution of these multiple transactions. When the multiple transactions are being executed simultaneously or concurrently, what kind of control can be enforced so that it will leave the database in consistent state. Thank you very much.